Hello everyone, this is Sivasubramony, a second year PhD student at the Center for Atmospheric Sciences at IISc Bangalore. Right now, I'm going to present what I'm going to do as part of my research. The topic is a new understanding of tropical circulation in a changing climate. Ever since the advent of global warming, climate change has always been more focused in the polar regions. Since 21st century, climate change has manifested into the tropical regions in the form of floods, droughts, and increasing cost or loss of life and property. If you can see this is the cost of 21st century natural disasters. You can see an increasing trend, particularly in India in this century, and this is an example of 2025 floods. 2020-25 was one of the costliest in record for climate-related disasters, with losses exceeding 120 US billions. Even though the technology has improved, models have improved, but they often struggle to reliably predict extreme events, particularly in the tropics. To understand this, I would first like to start with just understanding what's going on, what has been understood about tropical circulation. Tropical circulation has been idealized as Hadley cell, which is basically a zonally average concept. We are ignoring all kinds of asymmetries, but on the other hand, we have the Walker cell, which clearly shows that it is zonally asymmetric, and this is the reason why just a two-dimensional theory is not enough. The two-dimensional representation was good enough, but it is a massive simplification. Tropical circulation is zonally asymmetric. We need to move away from 2D representation to 3D representation. And these are my research objectives. First of all, as part of my strand 1, I like to understand the three-dimensional structure of tropical circulation using theory, observation, and reanalysis datasets. Second part is where it's computationally intense, where I'll be using fully coupled high-resolution Icon Earth system model developed by Max Planck Institute to quantify the interaction between circulation and convection. And to combine both the results from both the strands, I'd like to enhance tropical climate predictability using the insights gate. Finally, what I expect out of this research is a development of a unified three-dimensional framework which links Hadley-Walker circulation and ITCZ variability across multiple time scales and zones. Finally, I'd like to contribute to enhancement of tropical climate predictability, particularly in the context of Indian monsoon. And in a personal front, I'll become an expert in high-performance computation and Earth system modeling. I like to end with an image of a satellite image which shows uniformly an asymmetric view of ITCZ.